Okay, so we need to get through all of differential equations before your CBA, which is going to be a lot of stuff given that you guys are gone Thursday, I'm gone Friday. So I am going to review, I am going to record notes for you on Friday. The sub is going to play them. You're going to have to pretend that I'm here. Okay, because we can't get behind or you're going to fail your CBA and I can't move the CBA, huh? I won't be here Friday because Ashton has his surgery, his hand surgery. You will watch the video. I will send out the link to you and you will watch it. Okay? So, a differential equation, ready? We're starting our next unit. Okay, a differential equation is an equation that involves a differential, which is a derivative. Okay, so technically, if I give you a velocity equation, that's actually a differential equation because what is velocity? It's a derivative, okay? So don't let that word confuse you. A differential equation is an equation with a derivative. Now, a separable differential equation is an equation where you can separate it into x stuff times y stuff. Now, it does not initially have to be written like that, but you would have to be able to fix it to be like that. Now, technically, if you can write it as a divide by, okay, that also counts as separable because the x and y things could be written as a product if you made it like 1 over whatever. Okay, so here's what I mean by that. I want you to write down two equations. First one is going to be this. And second one is going to be this. Okay, one of those two equations is separable. The other is not. Which one is separable?
2x.
Okay, the second one. Here's why. What can I take out of both of the terms on this one? 2x. So now look how it's written. It'd be 2x. 1 plus, bless you, sine y.
Wait, so does it have to be the same one, or can it be like 2x like 3x?
As long as you could take the x out, that would be fine. So yes. Okay? So notice that the difference is that this one I was able to fix into x stuff times y stuff. If you can do that, it's considered separable. Okay, this is not separable. Because although the terms are separate, they're added together and there's no way for me to rewrite it so that they could be multiplied. Okay? So we are going to solve number 1 while we do the steps. Okay, when you eventually one day maybe go to college, okay, you will take an entire class on differential equations and it will suck. But for the AP test, not so bad. Okay, they get into a little bit of hard stuff, but not too much. So look at number 1. The first thing that we're going to do is we're going to separate. That is step 1. So why does it have to be separable? Because you're going to separate. So look at number 1. Here is how that looks. I have dy dx negative sine x over 2y. Here is what the separation process looks like. Anything that has a y needs to go to the left with the dy. Anything that has an x is going to go to the right side, and it's going to stay with the dx. Okay, so those are kind of like the team captains. You have dy and all the y stuff, dx and all the x stuff. Huh? Okay, so ready? How do I cancel out a divided by dx? What would I have to do? Multiply by dx, right? So I put a times dx here, cross it out, and I put a times dx here. Yeah? Okay, then how do I get rid of a 2y off the bottom? So divide by 2y, so I need 2, multiply by 2y. So I'm going to put a 2y here. Technically, I'm putting a 2y here, but then they cross out. So this is what I have now. This is the separate step. I have 2y dy negative sine x dx. So 2y dy negative sine x dx. So far so good? Okay, so all the y stuff on the left, all the x stuff on the right. Step number 2, you are going to integrate. And you are going to do it on both sides. Like an integral. So you're going to put one of these. Antiderivative, yep. Okay, so we're going to do the integral on both sides, and your solution will be the general solution. Now remember that general solutions always are going to have a plus c. So what is the antiderivative of 2y? So it would be y squared, right? We're doing the antiderivative. And then divide by 2, so it'd just be y squared. Other side, what's the integral of negative sine x? Cosine x plus c. Yes, okay, so technically you have a plus c on both sides, but think about, let's say that this c was 7 and this c was 1. Could I just minus this c across and make them only 1 c? Okay, yes. So when you integrate on both sides, you're not going to put an integral or a plus c on the left integral. Yes, so remember that when you integrate, these guys go away together. That's kind of like, d dx is a derivative, integral dx is an antiderivative. Okay, so both of those go away at the same time. That's correct. Okay, so from here, step number 3 is you're going to solve for y equals, and then you have a little star because that is only if it's possible. Okay, we will look at some examples where solving is not possible. However, for this example, it is. How do I get rid of the squared? Square root, square root. So that means that y equals plus or minus the square root of cosine x plus c. That is the general solution. Okay, step number 4 is going to be to solve for c. Okay, and that is going to be considered the particular solution. The particular solution, okay? So I have my general solution. Now I'm going to go back and look. They have to give you an initial condition or an ordered pair. So the initial condition they've given me is right here. So negative 2 is the answer when I plug in 0. Negative 2 is the answer when I plug in 0. Now, this is very important. Your general solution is a plus or a minus. Your particular solution, you have to pick one of those. So if my y value is negative 2, which one am I going to pick? On the outside, the positive or the negative? You're going to have to choose the negative. Okay, you can't keep both. You have to pick one because it's particular. So I'd have negative 2 equals the negative square root. And then what is the cosine of 0? 1 plus c. Okay, then from here I'm going to square both sides. Remember that when you square a negative, what happens to the negative? It's going to cancel out as well. So negative 2 times negative 2 is positive 4. Negative square root times negative square root is just 1 plus c, which means that c is 3. Okay, now remember, they're asking you for the solution, so you can't leave it in pieces. You need to put it all together. So it'd be y equals negative square root cosine x plus 3. Now, in this case, if you had come over here, slashed out the c, and put a 3 instead, would that be correct? No, because it's a plus or a minus in that stage. You chose the minus. So you want to make sure in your particular solution, okay, that you no longer have the plus or the minus option. Okay, look at the next one. Okay, it says find the solution to the differential equation dy dx equals. Okay, then it's 12x square root y. Now notice, I'm writing it where the 12x and the y are separated by multiplication. Now, if these are multiplied right now, where my square root y is on top, where will it end up when I move it to the left side? It's going to end up on bottom. So my dx, I'm going to cross it out and put it here. And my square root y, I'm going to cross it out and I'm going to put it here. So I have this now. 1 over square root y dy. 1 over square root y dy. And 12x dx. And then from there, I place my integral on both sides. And we're going to do our antiderivative. Okay? Now, before I integrate that left side, I'm going to rewrite it. If it's 1 over square root y, what is that the same as? Good. Y to the negative 1/2. Okay, so let's take the antiderivative of that. I'm going to add 1. Negative 1/2 plus 1 is positive 1/2. Then I have to divide by 1/2, so I'm really multiplying by 2, because remember, you flip it. So if I want to divide by 1/2, I'm going to times by 2. Now remember, the y side does not get a plus c. Other side, I have a 12x, 6x squared plus c. And remember that his c counts as the constant for both sides. Okay, from here, let's keep solving. How do I get rid of the 2? Yep, so this 2 right here. Because remember, we want to get y by itself. So I'm going to divide by 2 here, and I'm going to divide by 2 here. Now, quick question. Okay, when you divide by 2, so I have y to the 1/2, that's really a square root y equals. Okay, 6x squared divided by 2 is a 3x squared. Okay, with the c, did we know what the c was to start with? No. If I divide it by 2, do I know what the c is? No. So you're going to just keep calling it c. You don't know what it is. It doesn't matter that you divided it by 2 because it's still unknown anyway. Okay? From here, last step, what do we do? Okay, square and square. So I have y equals 3x squared plus c squared. This is the general solution. We need to find the particular solution by finding our c. So 25 is the answer when I plug in 1. Okay? Then from there, 3 times 1 squared is just 3, so really that's a 3 plus c. No, you're not retarded. Yoel, you're trying hard. I like that. Okay, then from there, square root both sides. And if 5 is 3 plus c, then what is c going to be? C is minus 3 minus 3. C is 2. Good. Okay, if I leave it like that, remember, that doesn't count as a particular solution. Okay? So it would be y equals... And that's your particular solution. Good? Did you figure it out?
Yeah.
Okay, cool. No. Okay, you're a sweet... No, we're not going to laugh. That's mean. Okay? No, I was coughing. Quietly coughing in a way that might have sounded like laughing. Okay, ready to turn the page? Good? Okay, so your C on that one came out to be 2. Okay, let's do... Yeah, let's just do number 3. Okay, take a look at it. Separate it first. When I separate, where is the 2y going to end up? On top. So 2y is going to be over here, and then where is the dx going to end up? On top. So now I have 2y dy negative 9x squared dx. Okay, from here, we're going to integrate on both sides. Integral, integral. And remember that your integral has to have a dy or a dx with it to tell you what the letter is supposed to be on that side. So the integral of 2y dy is what? Y squared. The integral on the other side is what? Yep, plus. See? Then from there, what do? Square root, square root. So that y equals the square root of negative 3x cubed plus c. Why is my general solution wrong? Plus or minus. Remember that your general solution, you have not chosen which sign you want. Okay, now.
Do we have to box that or no?
I would say on the AP test, don't box anything.
Like even your right answer? Like
Yes, correct. Don't box anything.
Ever?
Yeah. Because, for example, I'll show you why at the end of this problem, okay? So let's keep going. So we have a point here, negative 3 and 1. So negative 3 is the answer when I plug in 1, yeah? Okay, so first thing I'm going to do is choose the sign that matches my y value. So if I'm at negative 3 on the left side, I need the negative on the right side. So I'm choosing the negative. I'm going to rewrite. Because it has to match your y value. So if I pick a positive on the outside, then I'm not going to be able to find a c to make that happen, no matter what c I pick. Okay, then in here, 1 cubed is still 1, so that's really just a negative 3. Okay, what do we do next? Square, right? And when you square a negative, what happens? Crosses out, so negative 3 times negative 3 is positive 9. Negative square root times negative square root is just the middle. And then I add my 3 across. C is 12. Okay, this is why I would say not to box your answer. Yes. Is that if some of y'all get in bad habits of boxing weird stuff. Okay, Yoel has told us all about his woes with this, that he boxes the wrong thing. Let's say that you circle or box that. Did you circle the particular solution? No, now you don't get a point. Okay, what if you box that? Still, you're circling the wrong thing, and if you circle the wrong thing, that tells them that you didn't understand the question. So it's just safer to not box it. They'll look on your paper. If it's there, you're good. Now, if they looked at my paper, is it there? No, I still have to write it. So it'd be minus square root negative 3x cubed plus 12. Now, the way I've written that, I could lose a point, because why? My square root should end where? Over the 12. So that's where you have to be really careful as you're writing these things.
When you square both sides, you include the minus or the negative in the parentheses?
Yes, because think about what you're doing. If I can just expand this step, is it's negative. So when you multiply these together, the outside negatives cross out, the square roots cross out, but the negative 3 on the inside is protected. So it would stay there. Okay? Okay, look at the next part. It says, what is the domain of the particular solution? Okay, so this is really a pre-cal topic, but they do put this on the AP test sometimes. If this is your equation, how would you find its domain? What? I can't hear you. Huh? Okay. No, you don't have to set it equal to 0. Okay, you're kind of setting it equal to 0. What are you not allowed to square root? Let me be more general here. It can't be negative. So what you need to do is say, okay, so not equal to, greater than, or equal to, right? So I would say this stuff in the middle is not allowed to be negative. So I'm going to set negative 3x cubed plus 12 greater than or equal to 0. Because you are not allowed to square root something that is negative. Now, can you square root something that's equal to 0? Sure. You can square root 0 or a positive, but it can't be negative. Now, whether or not you solve that depends on whether or not they make you solve it. This is already the domain, but if it was multiple choice, you'd have to know how to solve it. So we're going to practice it. First thing I'm going to do is take my plus 12, I'm going to move it over. So that now I have negative 3x cubed greater than or equal to negative 12. What is my next step if it was multiple choice and I had to solve it? Divide by negative 3. Anything magical happen? You have to switch the sign. So now it's x cubed less than or equal to. Remember, that's one of your steps. Okay, then from there, negative 12 divided by negative 3 is 4. Let's pretend like it was a negative 4. Could you cubic root a negative 4? Yes. Okay, but in this case it didn't. So cubic root, and we would say x has to be, I'm going to write it up here, less than or equal to the cubic root of negative 4. That is the domain. Oh, did I say negative? Okay. Now, why can it not be less than that? Because that would make the middle of this negative, and you can square root a negative when you're dealing with real numbers, which is all you'll have to consider for the AP test. Got it? Okay, great. Yes? On the first part. Oh, you mean the negative on the outside?
Yeah.
That is correct. That wouldn't make a difference. You'd still only be setting the middle greater than or equal to 0. Okay? All right, number 4, we're going to go ahead and skip, but I want you to look at the way that it's worded because the AP test will sometimes do this. Do you notice that instead of telling you dy dx equals, they tell you that that's the slope? That's the same thing. What is the notation for slope of an equation? Dy dx. Okay, so don't be tricked by that. If they tell you it's the slope, that means that it's the dy dx. They're just giving it to you as a word instead of as a math expression. Okay? So if they say slope, you write dy dx. Okay? All right, skip it. Go on to number 5 because that one is very similar to the one we just did. Okay, taking a look at, should we do it? We'll just give it for now. Okay, number 5, look at it. Separate it for me. I want all the y stuff on the left, all the x stuff on the right. Okay, some of us are really distracted by phones, so let's just whoosh, put it away. Okay, number 5, we are moving the dx up. We are moving the 4y minus cosine y up. What is our separated version going to be? Okay, 4y minus cosine y dy equals. Other side will be, good, integrate, integrate. Okay, on the left side, what's the integral of 4y? 2y squared. What's the antiderivative of minus cosine? Positive sine y. Good. Okay, remember no plus c because I'm just going to let the plus c be on the other side. Antiderivative of 3x squared, what's that? X cubed. And then plus c. Okay, now look at your general solution. Can that be solved for y equals? No. Okay, even, I don't know, Miss Grissom couldn't solve that for you. No one can solve it. But is it still a general solution? Yes. So this right here is your general solution. Okay, it cannot be solved. It cannot be solved for y equals, but that still counts as a general solution. Now, just because it can't be solved, does that mean that you can't find c? No, you can still find c. So, come up to right here. Here's your point, 2, 0. Okay, and we are going to find the plus c in the equation. So, find plus c, 2, 0. Here we go. This is my x, this is my y. So, here I have 2y squared, that's 2 times 0 squared. Plus the sine of y, which is the sine of 0, equals my x over here is a 2 cubed plus c. Now, 2 times 0 is 0. What's the sign of 0? So that's 0 equals 2 cubed is the same as 8 plus c. Then what's your c? Negative 8. Very good. Now, can you still write your particular solution? Yes. It's just not in y equals form, but that's fine. So it'd be 2y squared plus sine y x cubed minus 8. That is your particular solution. Okay? Yes?
Not that it really matters. Isn't this integral
Snow cone, negative, negative. Oh, it is negative sign. Look at this. We made a mistake. And then over here, it would be a minus sign 0. Now, the good news is what's the sign of 0? So it didn't end up messing up our C, but you are right that on the AP test, you wouldn't get credit if you had the wrong sign there. So it should have been. Okay, so let me break down the way that they do it. You get 1 point for separating. So let's pretend like Zakaria hadn't found our mistake. Okay, would we have still separated? 1 point. Then they give you usually 2 points, 1 for integrating the left side, 1 for integrating the right side. Would we have gotten our left side point? Would we have gotten our right side point? Yes. So you still would have gotten 2 out of those 3 points, but you would have lost a point for integrating that side wrong. Okay? All right, part B. What is the domain of the particular solution? Okay, domain is x. Look at x. It's an x cubed. Are there any numbers that you're not allowed to cube? No. Versus a square root, are there numbers I'm not allowed to square root? Yes, all the negatives. But if it's a cubed, you would say x within. Do you remember this? No? What does it stand for? Nobody? All real numbers. Very good. Okay, so if you ever see that symbol, that just basically means there aren't any restrictions. Okay?
That doesn't even look like English.
Doesn't look like what?
English.
Yeah, it's not English, actually. It's, I think, like Latin or some Greek, maybe. I don't know. I have to look it up. Okay, can I turn it? Okay, our goal is to get through one more, and then we'll save the rest for tomorrow. Okay, so turn the page, please. And I'm going to bring you a little sweet tart, and you're going to do A, B, C. A, B, C. You can do it. Go. And I do want you to solve it for y equals, please. Okay, so you're separating, integrating, getting y by itself, and then solving for c. So it ends up on the top. Well, you have to integrate the y. So it'd be 1/2 y squared. You know how you like add 1? Okay, put your integral here. And here we go. And put it here. Okay, so the integral of y would be y squared. Because you have to add 1. And then divide by 2, so it'd be a 1/2 y squared equals your other side of the equation. Plus c. And then from there you'll times by 2 all the way across. But remember that the c is going to stay a c because you don't know what it is anyway.
Thank you.
2y squared equals.
Well, hold on. If you times by 2, you cross out. That's the whole point is you're trying to get y by c. So it'd be y squared plus c still. And then to get rid of the squared, you'd have to take that. Come on. You can do it. Okay, so do your separate first. So if your y starts off on the bottom, it's going to end up on the top. And if your dx is on the bottom, it's going to end up on the top. But they'll switch sides. Okay.
Okay, so it'll just be I squared plus 6x.
No, you're missing, that's not the right answer. Okay, or one. You integrate y,
Oh,
y
y'all.
squared.
Okay, I got this.
Oh yeah, cause you add.
Yeah, I'm about to get hooked on the CDS.
And so now, once you times by 2, you're gonna have to square root both sides.
Marcel, you always say that and you don't.
Last time? Okay, last time.
I'm about to say that, but I was like, maybe not. Let me see if he gets another time. But I was like,
Alright, we'll see.
Happy late Valentine's Day. Uh-huh.
let me not say anything.
Okay, and then you need to square root. So now I would go ahead and times
Okay,
the
I'm
2.
stuck now.
You can leave it separate, it's not wrong, but I would wonder if it would just, it's kind of pointless to leave it
Square
separate.
root. Square
What
root
is it?
6x squared.
Can you take out the
Yeah. I waited until the day after Valentine's Day.
100 of this is yay.
No, I have the concept down. I just get stuck.
Yes,
Well, how do you know which sign to choose? It matches your y.
it has to match what your y value is. So in this case, your y value is positive, so you'd be picking the positive.
Dude, I stored it. Dude, I accidentally stored some of that sweet tart powder.
Okay.
It was an accident.
Antiderivative of y is? Antiderivative of 6x is? 3x squared plus c. Okay, then some of y'all did this. Okay, and you left the 2 in the front. I'm going to have to put it on this side because I didn't leave enough room. That's weird. Don't do that. It's not wrong, but it might make finding your c harder. So when you times, it's y squared, 6x squared, plus c. Remember, you already didn't know c. You don't care if you times it by 2. I would just lump it all together. It's not wrong to do this, but it might make your solving harder and lead to you making a mistake. Okay, then from here, square root. Okay, from here, solve for the particular solution. 1 is the answer when I plug in 2. 2 squared is 4 times 6 is 24. Okay, plus c. I still forgot to do what? You have to pick the plus or the minus. Which one will I pick here? The plus. Okay? Then from here, I'm going to square both sides. 1 squared is still 1. Square root and squared cross out. It's a 24 plus c, which means that c is negative 23. Okay, then I write my equation. It'd be y equals the positive square root 6x squared minus 23. Or if you wanted to put plus negative 23, fine. That's not wrong. Okay? Okay, look at part C. What is the domain? Domain is x. Are there any x's that I can't put inside the square root? Anything that will make the square root expression less than 0. Okay, negative. Correct. So I'm going to let 6x squared minus 23 has to be greater than or equal to 0. Now, why can it be equal to 0? Because you're allowed to square root 0. Okay? So I would bring my 23 across. I would divide by 6. So I have x squared is greater than or equal to 23 over 6. Now, hopefully they would never do this to you on the AP test, but do you remember that when you square root the squared, you have to break it up into 2? Okay, so technically when you do this, it would be greater than 23 over 6 in the root, or, and then this negative 23 over 6. Okay, this is supposed to be an or. Yes?
When you multiply the 2, it doesn't go to the c.
So remember, you already didn't know what c is. So that's why it doesn't really matter if you times it by 2. I would just keep calling it c until the very end and then find it. Okay? Now, here is why I would say you shouldn't solve stuff unless you have to. Is that 95% of y'all would have forgotten that this splits up. The only reason I even remember that is because we literally just covered it in Algebra 2. Okay, so if you got to there, you would have lost your point. So if it's for your response, you go here, you're done. That's it. Okay, versus if it's multiple choice, they can do weird crap like this, but probably they won't. So that's where I would say set it greater than or equal to 0, leave it alone. If you have to solve it, do it. But there's weird stuff that happens with inequalities and squares. Okay? All right, last part. Last couple parts. Okay, what is a linear approximation? This is old school. Look at your little things I'm circling. You remember?
Where you like plug it in.
Yeah, what do I need to plug it into? The equation of the tangent line. So right now on your paper, linear approximation, I want you to write tangent line. That's the same. Okay, they're changing the words around to make it confusing, but a linear approximation is plugging into a tangent line. It's just a different way of saying it. Okay? So what two things do we need for the equation of a tangent line? Okay, a point and a slope. What is the point that they're giving me in this part? 2, -1. Very good. How will I find this slope? Will I need to take the derivative myself? What did they give you? The derivative. What's dy dx? 6x over y. That's your slope. So all that I need to do is plug in to 6x over y. Now, the notation for that, in case you've forgotten, is dy dx line to -1. Yes, you need to correctly label your work if it's free response. Okay? So dy dx line, and then you put the ordered pair. On top, I want 6 times x. On bottom, I want y, so my slope is -12. Good? Okay? Then from here, I'm going to write the equation of my tangent line, plug in my random decimal they give me, and then you're done. So it'd be y plus 1, -12, x minus 2. Then from here, some of y'all like to solve it. Fine if you want to do that. Okay, but I'm going to go ahead and just take my 2.1, and I'm going to plug it in right there. So f of 2.1 then would be y plus 1 equals -12 times 2.1 minus 2 is 0.1. What do I do with the decimal on 12 if I'm timesing by 0.1? I make it 1.2, right? It moves the decimal to the left one place when you times by 0.1. And then to get rid of the plus 1, I have to minus 1. So it'd be -2.2. Now, remember that if this wasn't multiple choice, you could have done this. Look, this is like the kind of lazy but smart version. Okay, -12 times 0.1 minus 1. That's good enough. Okay, you don't have to do the math. If you're not confident with the decimals and stuff, then just don't. Okay? Alright, part E, this is also throwback. What do you need to do to find d squared y dx squared? Okay, that is the second derivative. Now, I already have the first derivative, right? What rule are you going to need to take the derivative if dy dx is 6x over y? Quotient rule. Very good. See if you remember how to set it up. We'll do it in a second. Because the hose on the corners. Marcel laughs just as hard. Oh, maybe you didn't hear the joke, though, back then.
Yeah.
Because you were taking a nap or something, you know. This was the old Marcel. New year, new you. Okay? So if my high was 6x, what's the derivative of that? What's d ho if ho is y? dy dx. Good, you remembered. Okay, if it's a y, the derivative's 1. but then you have to put a dy dx on it because it's not an x. Okay, from here, it's ho d high, so that'd be 6y, minus high d ho would be 6x dy dx, and then over ho squared is going to be y squared. Okay, I just made what's called transitive property error. Okay, when you put in equals, it means it's equal to the thing before it. So, is this equal to this? No, then I lose a point unless I fix it. What changed? This was dy dx. What's this? D squared y dx squared. So make sure that you're not just setting random stuff equal to each other. Okay? Now, read the instructions again and tell me what's wrong with our answer. We would not get full credit for this answer because of a detail that's in the instructions. In terms of x and y. That means that the only letters allowed in your answer are x's and y's. Is dy dx allowed?
No.
No. So to fix it, you would just bloop, plug that in. So it would be 6y minus 6x, bam, dx over y. Y squared. Okay? The difference is that this is in terms of x and y. This is not. You would still get partial credit, but you wouldn't get full credit. Okay? Then the last part, how do you determine if the tangent line's above or below? Do you remember? Concavity. We'll do that one next time since we're almost out of time. Okay? Good job. Pay for your AP test if you haven't already.